NRCS session with Rory Karhu, and Dixie, and he'll introduce Richard for us. So, thanks for being here.
All right, well, appreciate you having us here. As you said, my name is Rory Karhu. I'm the district conservationist with NRCS here in Park County. Dixie Michael works with me there at the office as well. We had brought a producer in. I know some folks are interested in learning about our programs, but being a time when we don't know what our new farm bill is going to look like, I didn't want to talk a lot about the farm bill and what we expect is going to be in the next one because nobody knows. What we do know is some of our programs can be fairly beneficial to producers in actual structures and things that we can cost share on the ground, but also minimizing risk to try something different. And the producer we have in here today, Richard Schlenker, that's what he's going to talk about, is a couple of different programs and how it benefited their operation. So Schlenker Ranch, the two programs that they implemented and he's going to discuss is the Conservation Stewardship Program. And under that program, the idea behind that one is rather than pay producers, and it's a cost share on installing an improvement on the irrigation system or doing fencing for livestock grazing, that type of traditional project. This program looks at their operation as is and gives them a score basically for what they're already doing. So they get credit if they're doing some good things on their operation. In addition to that, they have to select some enhancements, and there's hundreds of these enhancements available. They select the enhancement. It can be as many as they would like to try to do, or as few as one. But their score is related to how many enhancements they decide to do on their own. And those enhancements don't provide any cost share for those. They have to install it or implement that management technique on their own. Okay, and there are several of them that Schlenker Ranch did. The one they're going to talk about here is tissue test for nitrogen management and what they found on their operation. And I guess to follow that up, once the enhancements are installed or applied, then they get an annual payment. And what it does is it sets the risks and encourages a producer to try something that isn't maybe being done on a large scale in that region. Okay. And then secondly, the old standby environmental quality incentives program, the most used program, at least here in Wyoming, and the one that's funded the greatest. It's for traditional actual practices on the ground, where a guy has a dirt ditch and he wants to improve maybe to a pivot or maybe to a gated pipe system. Richard's going to talk about improvements in irrigation efficiency, and also how it relates to things like application of nutrients. But it's in what we call a complete buried line, gated pipe, and surge valve system. That really, the projects that we're cost sharing on now, the idea and the methodology really came from Schlenker's. Okay, and this is my last slide before Richard gets up here, but up here is just the installation of the buried line, pouring some thrust blocks around the T that's going to come into this valve that controls the water that runs into the surge valve here. And the surge valve is kind of the key component to this whole system. And with that, Richard, it's all yours, and I'll let you give them any details about yourself.
My name is Richard Schlenker. I farm and ranch with my dad on the Grayville River between Matiti and Burlington. I don't know if any of you know really where that's at, but and then we also farm in Emden and down by Otto as well. We span 30-mile radius there. So I'm going to start off by talking about how many people in here know what a surge valve is, or has heard of one or seen one before? Show of hands. 1, 2. That's the start. What they are, they're little metal inside of here is a butterfly valve. What happens is the water comes in, and then it's got an electric control panel that switches it left and right. And the main purpose to that is to increase irrigation efficiency in furrow applications. there's a lot of problems. Pivots are really high efficiency, people go into them a lot. What do you do when you have a field like this, and then you got a highway that runs through here? You can't do something with the highway, so you have smaller field, and then to make it worse, we'll have slope on a sideway. That's a little bit drastic, but we can have 50 foot of fall in 600 feet, that's a lot of fall. And not all of our fields are this bad, but really bad. So we have extreme erosion, and pivots, they don't fit where we live in this valley. So you need to increase your irrigation efficiency and your nutrient applications. So you start looking into mechanized irrigation. There wasn't a lot, so we started looking at surge valves, and we found out, and what the basic principle of surge valve is. The water comes in, if here's your field, like this, and your head ditch is up here. How they work, water on a normal field, if you set it for 12 hours, you set your tube or your pipe, and water runs across this field for 12 hours. It takes all day to get across, and then water just soaks. So then when you have stuff like nitrogen, it leaches. So at the top of your field, the water's running on the top of this field, it's ran for 12 or 8 or 10 hours. And the bottom of your field's only had a couple hours if it barely makes it across at that point. So what do? You have the effects of your nutrients, like nitrogen, it leaches with water. So as an underground effect, as nitrogen moves with water, so you get a percolation effect. Your top is soaked up, and it comes to this. So there's hardly any water here, and a lot of water has been applied to the top. And where does your nitrogen go? Your nitrogen goes straight down. So you have this effect. So how a surge valve works, and it's really important. It's really hard to get them. It's not hard. It takes a lot of time and trial and error to get one set. You have a control box, and this right here, they're electronic. This is a basic one, but you set your advance. You figure out, and this changes as the season goes on, because the very first application, when you're trying to irrigate something like a set of sugar beets or something, the very first time you push water across the field, it might take longer. So it might be set your advance for 6 hours. And after you've had your water across once, it might only take 3 hours to get across. But you figure out on each field and each set how long you need the water to get across. So let's say it's 5 hours. So what happens is it starts out, and these times aren't exact for a 5-hour set, but the first set, and they go from the top, and here's your surge valve. The water comes in, it goes to the left. It'll go for 5 minutes, let's say, the first time. And the water will matriculate to here. So, and then it'll switch to the right, and it'll go for 5 minutes. So then it goes that far to the right. Well, then the next time it comes on, and it'll go for like 12 minutes. So then the water advances to here. And then when it's off in between there, what happens to the water row, I don't know if how many people in here have irrigated up like corn or dry beets or sugar beans or anything like that? Anybody? What happens when you do that the first time is, what happens, I don't know how to explain this, but after you've pushed water across that row the first time, it's easier the second and third time. Well, what this does when it goes the first time, it wets that row and it seals it off. So then your percolation is only went a little bit. And the cycles keep advancing. So then the third cycle it comes on, goes left and right, it might go for 35 minutes. And then finally, you've done one for your fourth cycle will come to the end, and it'll be, maybe it's a 45-minute cycle. And all those cycles add up to a total of 5 hours to get the water across. And what you want to do is you want to get that set so about 90% of your rows are just barely getting to the end. You don't want, so you don't lose all the water off the end into the wastewater. It gives you the ability to, just as far as water management goes, your top is no longer than percolating down. The top is only a few hours wetter than the bottom, so your water profile becomes more straight instead of a steep curve. Your nutrients are not leaching. It requires way less nutrients to do the same amount. And you also, at the very end, what happens, you get it set. Because after the advanced cycle's over, it goes into the soak cycle. And you can set your soak cycles as many number of soak cycles as you need. Like if you want to run it for 6 hours or 12 hours or 24 hours, then what happens is you can percolate this down in even sets. It gets the top as wet as the bottom because it's only ever on. What happens is approximately, if it was a 5-hour set, it probably is going to go to about a 20-minute set, so then it shoots. And you want this to be switching back to the other side just right before they get to the bottom, so almost no wastewater. So you get up into an 80 to 90% efficiency rate, about 85%. What happens is the water, it's like a pivot. The water you apply to that field stays on that field and it goes into the ground. And the other thing it does is if you're used to running, like let's say this is 5 pieces of gated pipe each way, well the same amount of water that comes in, you would normally just set here for 12 hours, 24 hours, 6 hours, 8 hours, whatever you're doing for your sets. Now in that same time frame, you're getting twice as much coverage in the same amount of time. So you're getting a piece of pipe 30 foot long, so instead of getting 150 foot of the field, but you're getting 300 foot in a 12-hour period. 12-hour sets are pretty common. If you guys don't, just call or you have any questions, just ask.
How long is the programming? So you said it's kind of complicated approach. Make sure you're not advancing fast.
Well, it takes a little bit of trial and error on every field, and it's a little different for each crop, and the years play such a big difference. Like if you plant something to get a rainstorm, obviously your advance time is going to be slightly shorter. Because so it's a little bit of trial and error, but you learn after you've done it a few times.
So you got to do it every year, though. You can't set it.
We know
particular field.
once you kind of done it on a field, you kind of get a feel for it. And you have a notebook or something, and once you've done it, once you understand, it's just getting the initial feel set up is a little bit different.
So as you're listening, I'm going to list some of the benefits
Go ahead.
that you're seeing, and I guess what NRCS is assuming when we cost share on these as well. Because where Richard has taught us a lot about this, is that if a pivot doesn't work, then basically the Cadillac that we have now is this system. Okay.
In a field where we have these slopes, what we have, it takes a lot less water per row. Like if you were using a certain size tube before and you're putting out a certain number of gallons per minute, it takes roughly 2/3 to half that amount of water to push it across in this manner. It doesn't take as much as it does when you just set it there, because it just soaks and soaks and soaks, and you're turning your black, if you got your rows here, and here's your bed, and you got your plants planted here on your bed, and you're irrigating down, should use a different color, and then you're putting your water in this row, and you got it on here, every 44 inches you're irrigating in a row crop situation. What happens is you're pushing it down, and at the top, everything just soaks black across. And then at the bottom, you'll just have this tiny little strip where it's soaked over from the water row, like it might come over to here. But it doesn't get near, you're over irrigating the top, you're curved, you're washing it down. The top is just, on a surge system, the top and the bottom there, it's soaked over almost the same amount, top and bottom. Getting the advanced set, once you have it set, the soak cycles automatically occur, and it drives in this deep irrigation. And the other thing on these surge valves, I don't think you can see it, there's a port right here. And they have it's for fertilizer injection. So what you do is you go to each one and you pull your fertilizer trailer or your nurse tank or whatever you have, you park it here, and they have a pump, and it measures it out in gallons, and they have a fertigation cycle. So that's why it's really important, you don't want to push all your nutrients off the end. So you get your advanced cycle set so that about 80–90% of them stop, like right here. Just barely trickling out. And so you're not running it off, and you put it in fertigation mode. And it runs 2 soak cycles. And the pump meters it, you got to calibrate it, and then it counts off. And the beautiful thing is you know how long your runs are, you know exactly how many acres you have there. And you know if you want to put down 30 units of nitrogen, or 10 units, or 20, you know, you back figure that out to your gallons of product you need to apply, and you type it into your pump, you calibrate your pump, you type it into here, the number of gallons you want to fertigate, it'll go through the fertigation cycle, it'll run 3, you can change the level, it'll do 3 soak cycles, so it gets everything prepared for it to accept it, and then you can it runs 2 fertigation cycles, and then it cleans it out so none of the fertilizer is left inside of here, because it's kind of costly, and wash it out. And then you've applied your fertilizer throughout the season, in season, without going into there and disturbing things. And you can do it on the go. So as you're testing or something, you can figure out exactly how much you need to apply in season. It's not over applicated, because a lot of the problem is it's hard to front load with nitrogen because of leaching. And you can go through the season, but it's hard to get a window to apply the product in a timely fashion without causing it to rain. You get grain in different stages. You can't drive back out there, and you can't work it in. We have a lot newer fertilizer products like urea. They'll volatilize and disappear. So that's why smart nitrogens are coming on to make nitrogen less volatile. Well, you can do this, run it in the water. It's attached immediately through the pump and the controller. And it'll measure it out to the 1/10 of a gallon. It's very extremely accurate, extremely accurate. A lot of flexibility on, like take wheat for example. If you're doing wheat, if you top dress wheat all in the beginning, what it does, it's a luxury user of N. It will take it and grow a lot of, it'll stool and grow a lot of leaves and foliage, and you've wasted lots and lots of money in nitrogen. If you can turn back from like 3 to 4 units per bushel, all the way down to like 1 unit per bushel. Because you can apply it, when you apply fertilizer on a wheat field, if you'll wait till afterwards, instead of having all these little tiller shoots per seed, a tiller is if you have 1 seed of wheat, you have 1 main stem that produces crop, and every little tiller is like a sucker head. That's what a tiller is. And they'll come up and they'll produce a couple kernels and a couple kernels. The most efficient way to raise small grain, you take this and have 1 tiller. Well, if you have too much nitrogen, it promotes tillering. And it just wastes all your fertilizer, not just nitrogen, but nitrogen is the main user. And it's put into here. Well, every one of these is only worth like 25% of the main stem. And then you have low protein. It's where all your nitrogen, because protein's a function of nitrogen, variety, and yield. Obviously, the higher the yield, the less nitrogen will go around, so you have lower protein. Well, if you can apply it after it has got to the flag, what's that called?
There's a flag leaf.
Yeah, but it's not the flag leaf stage, it's before the flag leaf stage. It's the
Mid stage?
yeah, no. Anyway, you take the stem and you look inside of it, you pinch it with your fingernail, and it's when it becomes hollow inside. That's when you apply it, because the tillering stage is officially over. And I can't believe I spaced that out. It's a really easy word, not just spaced out. But when the stem is hollow, then you apply your nitrogen. And you can do that here really easily. But you can't do it very easily in a normal method, because you'll get it wet, and then how do you ever get back in there? That's just one. And then sugar beets or corn, the way we take it, and this kind of moves into the CSP program. We take sugar beets. Does anybody in here grow sugar beets?
So before you jump into CSP, can I go through?
Go through that real
See
quick.
if you agree with me on that. Water quality is improved, because as you're going across there, in that first run, that first 5 minutes, 15 minutes, that soil tightens up. The soil particles tighten up together. And so now, as you run across that, you're not carrying that sediment load to the end of the field and dropping it off into a ditch or whatever, right back into the river. So you've got that part of water quality improved, in addition to the fact that you're not moving, some guys, especially if you're doing broadcast nitrogen, you're not carrying it actually to the end of the field and dropping off. Water quantity, obviously, if you can do twice as much acres with the same amount of water, same amount of time, that's a huge savings on water quantity. Your nitrogen leaching reduced, as he explained. Overwatering top of the field is reduced, so your crop, you don't drown out the top end of your crop or dry out the bottom end. Labor savings is a huge one, because now Richard can go out there and have 300 feet of gated pipe set, but after the initial setting, for the rest of the year, essentially, by opening one valve and closing one.
I haven't. Yeah.
And so you don't have to mess with gates, nothing on that gated pipe. And then you reduce soil erosion. As we talked about on the water quality, you're not moving it to the end of the field as well, especially when you got steep slopes like Schlenkers have. And then finally, if you have the ability to fertigate in a fairly controlled method.
An extremely controlled method. I mean, it's very controlled. And what he's talking about, I don't know if you have, normally if people have a field, they lay out their gated pipe and they go from one end to the other, the water comes in here. And then and every 30 feet you got a joint and it just leaks everywhere. So you start out here, you got a quarter mile of it. And you start opening gates at the beginning of the year. And we'll have to do, on these sets, we run 30 pipes on these sets. You got to do that morning and night, and it takes such a tiny amount of water. You got to open every gate like this far. It's under pressure. It's pumped. I don't even know how to explain how much time and effort and energy, because after you've done it, you go to one field, one field, one field. Consistency, because you can go get them all set the first time. Because what we do is we come underground on this set. If there's 50 pipes here, we come up and we go 5 pipes left, 5 pipes right. And then there's a valve, a butterfly valve. So once you get it set initially, you go through, you get all those gates set the right amount so that everything comes across the field evenly, instead of having a gate open like this far, wide open, however far. And that would be this valve right here. You open that valve, and you turn the surge valve, and it goes each way the rest of the year. All you do is after you open it, you go along, you just check, make sure that the water didn't get out, pool out, get into the other one's pool, fix it, goes down the road. The time savings and the ability of a person, people can't go along every day, morning and night, and set 30 pipes the same every time, so that you have the same advancement of the water across the field every time. It just doesn't happen. Nobody's that good. So you can fine tune them all year long. If you got a row that's just a little slower, you finally get, after a couple times, every row set. It's just consistency. Consistency is key. Everything's the same, and then you can set these butterfly valves. They got little notches. They'll be on them. They open up. There's a circle here in the valve, and they're settable. They each have a little notch. You know whether you go 2 notches, 3 notches, and then you can, if you have more water or less water, you're either open 6 of them, 5 of them, 4 of them, 3 of them. This savings alone, just so it's repeatable, so everything's the same, it's repeatable. It's measured across in the crop, yields, everything. Repeatability is key. And not having it in an underground, having it in an underground pipe, it's there immediately. You don't have the ditch, you're not washing it away. The surge, we have fields with the slope. What would happen before, to tell you, when I said that we could apply the water in whatever water you put out there now stays. We have fields, when you would go to the top and set it, before you could drive back around to the bottom, the water beats you across. It's already run across. And then you clear it there for like 6 hours. Well, with this, you can set the surge valve down so it's switching like every 2 minutes. Left to right, left to right. You can go all the way down to a minute. That fast. And it literally just, whatever you apply stays in that acreage. I can really explain how well that makes it work. Because when we first tried it ourselves the first time on a field, before we tried to get NRCS help, we had a field here, and we put it out. We already had the underground lines, and we were just manually switching it by hand, just setting it, because just for the savings. And we put in a valve, we put in a couple surge valves. We seen them, so we put one here, and we put one here. Well, the sets, I wish I had pictures of this, but I don't. The ones under the surge valve, we irrigated it the same way we did the others, for 12 hours, so each side was still only getting 6 hours. 2 days later, in the middle of the afternoon, these crops, the ones that weren't under the surge valve, were laying down. They're turning dark in the afternoons. They'd recover in the day. These just stayed bright green. I mean, you could see it from miles. It's just like somebody sprayed something and tried to kill these in the middle of the afternoon on the other side. The water stayed instead of running across the field. Now, it's kind of a bad deal if you need wastewater, because we have places before that we put, we have like an 80-acre field, then we have a field down here. Well, we had no way to get headwater to this field, so the only way I got water was wastewater. After we put this in, there was never any water for that field. We had to then bury a line down to this field. Yields have increased probably 15 to 20% on average after we've installed these. It's the easiest, it's still a lot of work because it's still furrow irrigation, but you probably in your handbooks, I would say it probably turns to 80. Does it have an actual set of ground surge irrigation, what does it say?
For our efficiency,
Yeah.
it's pushing close to pivots.
They're run almost neck and neck at that point. So,
Whereas before, you know, if it's just
50,
a
60.
regular gated pipe, it's 50, 60 at the best.
it really increases the efficiency.
So have you ever looked at, you know, that if you get 15 to 20% increase in yield, have you ever figured out
That's
how
not
long-
necessarily on the flat field so much.
you see-
That's an average, like we'll see like maybe a 25 to 30 on a field like this where we just flat couldn't get the crop enough water because it's a frost, it won't soak over, the water's just going off the field. On a flat field, maybe we'll get 10%.
So if
the
a
average-
producer did that, you know, completely on his own cost,
It
how
would
many
pay.
years do you think it would take to pay? Because you got-
Depends a little bit on the crops he's growing, but these surge valves for a 12-inch one run about $3,000. So, and it really depends. That's a tricky question, 'cause it depends on the length.
Yeah, I kind
You
of-
can have a field that would be a half mile.
I just
long,
thought
so-
of it just now,
Yeah.
because you were discussing it since.
But it's a no-brainer. Like, we do that with you. We buy 2 to 3 times the amount we do it when we get an equip project. We'll buy 2 to 3. We buy 30 to 40 a year on our own. It's not every year. That gives you an idea, so.
Right.
Do you fertigate?
This kind of stuff. We fertigate our crops like sugar beets and corn, mainly, and wheat. We'll fertigate those. And the reason why on the sugar beets, and this moves into the CSP part of the presentation here a little bit, and I can trace back to this at any point, and it will kind of all blend together. But that tracer doesn't work very well. That's why I asked if anybody here raise sugar beets. You get paid on a percent of sugar, on your percent of sugar. Well, all sugar percentage, you can have a 16% sugar content, but you can't necessarily retrieve all that sugar because of a thing called SLM, which is sugar loss to molasses. I hope I spelled that right. That's SLM content. And in SLM content, one is neutral. So if your SLM is at 1.0, that's a neutral base. Anything below that, like if your SLM comes in at 0.8, at 1.0, they should be able to extract 80% approximately of this 16% of sugar per ton, is how that works. So, and anything other than that is lost in molasses. It's a dark sugar. So then they have to send it to the SLM plant, which costs a lot more money because they refine sugar beet sugar 3 times at the sugar grape factories. And the first time is your purest whitest sugar. The second time, it's almost as white. And the third time, it gets a little bit off color. It's not quite white. And everything that's left after that is a brown liquid. And it's molasses. So they come up with this number because all 16% sugar is not the same thing. So, and what causes this, the main cause of this number to be higher is nitrogen. It's too many nitrates. It's heavy metals is what causes it to be trapped in the molasses form. It's nitrates and heavy metals, and nitrogen is the biggest heavy metal concentrate. What we found out is we've always had higher SLMs lately up on these places, and especially since we did the surge valves, we're not leaching as much. On a normal sugar beet production, if you takes 8 units of nitrogen to produce 1 ton of sugar beets, approximately. That's the general rule of thumb. So if you want 30 tons, it takes 240 units at N. And then you do a soil test, you take off, and you back off, and then if you have 60 units available. So you're applying a lot of nitrogen. Well, if you're not leaching away as much as you used to, it takes less. Our SLM started going from like 0.8, 0.9, and 1.0. We started getting like 1.5s and 1.6s. So we had to start figuring out why. And we entered the CSP program, and Rory helped us start the tissue. We did a lot of enhancements, but tissue testing was one big one on high nitrogen use crops. So we would normally on a field start out, you would apply 60 or 80 units of N in the bed up, and then you would knife in up to possibly 150 to 200 more units, because you're shooting for 35 tons each, you could be applying 200 more units of N in the season. So what we started doing is testing soil testing. If you have a 40-acre field, you just kind of go across it and you pick a pattern here, and you take all these probes. On a 40, you're looking for about 20 probes, depending on the size of your probe. You mix it up in the bucket, you send it up, and you have a pretty representative sample. Unless you have a big alkali spot here, you try to skip that stuff, or a rocky ridge where the soil's real thin. Then you have a pretty representative sample. But tissue tests are fluid. It's a growing crop, so you find the newest sprouts. I can assure you, you go down in all those big leaves, and you find the two newest leaves you can find. They're little tiny. And if you got a field, you got it in rows, to have, because you can't just, with a soil test, you're pretty good with just one testing. In a tissue testing, it has to be done weekly, over a period from once sugar beets hit the 8-leaf stage, sometime in the middle of June, till about September. Tell you what, about 2 weeks before harvest. It isn't, and you take them once a week, and you have to take them, you have to hit the same beats. You can't just go skipping around because one guy might have a little more or a little less, so you have to place flags. And then you do it right on that beat, and you do the two on either side of it. So you go across, and you get, we call them straws. You end up with a wad of tissue about this big, and you send it in. And you have to take the same ones, because one test might be higher or lower on your N parts per million. So you might have to throw it out. It's an average. It's a running average. So what we started doing, and with this fertigation, is we figured out we'll put down 60 units up front, and we have fields now where that's it. We just take it all the way to the end. Without testing with the nitrogen, we didn't know it. We just did what you always did. It's just throw it away. So we come in with a 1.5, or it's the difference between a 1.0 and a 1.5 can be $200 or $300 an acre on a 30-ton crop. It's huge, and it's all because you didn't know what you're doing. You don't think you have time to do these things. You don't think that their tests are expensive. They're $50, $60 a piece. You do them once a week, twice a week, and you'll do more than one per field. So you're doing it in 2 or 3 spots on this field. They get really expensive. You don't know how much you're throwing away unless you test it. You can't make decisions without information. It's really hard to understand. And what this then did, after we started that, we figured out a better way. We don't have to use as much, like if we needed, if you send it off, and on a, how many people have seen a tissue test come back from a place? They'll have their recommendations at the bottom. Well, they'll say you need to apply 60 units a man or something. Okay. Well, you have to call them, because if we'd apply that in this scenario, it would be, we'd have to cut this in half versus normal recommendations to furrow. So the lab we use now knows when we send our tests and what they're for, but we would put in 30 instead of the 60 to get to the end.
Is there factoring in leaching?
They're just factoring leaching, and when you say Furrow Irrigation, they know the area where it comes from.
Because of the surge valve.
Because of the surge valve, you're not losing that hole right there. And then you can, the ability to apply it properly and have it attached immediately, the water attaches it to the ground. You have to get, if you have urea or any nitrogen, it has to be underground an inch before you won't start being, if it's above 70 degrees, the hotter it is, the further down it needs to be in the ground an inch and wet to keep from volatilizing. Have you ever seen people pulling their knifers or anything, or those coulter machines? When they're doing that, they're making a crack in the ground, and then like a back swept knife. It goes in the ground about 4 inches or something, and then the tube, the nitrogen, comes down here. We loop for nitrogen on the back side of the knife, and the knife is big. Well, even if you do that, there's a trench. There's nothing closes this back up. So your nitrogen's in the ground like 3 or 4 inches. Nice depth. But this crack is open. And when you put water in it, it'll go right in there, and sometimes it'll just float right back because it's not mixed homogeneously with the water. It's not in the water. It's not a homogeneous solution. So it'll go down in there. It'll grab this loose dirt, and this loose dirt will come up and float away. You lose nitrogen. This is a really efficient way versus just spray it on the ground, but you lose the efficacy of the nitrogen. I don't know what percent it is, but in that scenario, you lose a lot. That's another reason for this lower amount in that application versus just a knifing application. And
So what were you able to cut from?
normally we went from like 240, and now a lot of places we're running 60 and 80 units in the places we have surge valves, and we've cut about 80 units, or well, almost 200 units.
So it's helped you on your SLM.
drastically, because now we're
So
running
there's
back.
money in that.
There's money in that.
But there's also more than half, or less than half of the nitrogen.
Less than half of
Which is
nitrogen.
pretty significant, how much per acre there?
Nitrogen per unit, if you want a unit in, it runs 75 cents to $1, depending on if you're on the dry form or liquid form at today's prices. So you're saving $200 an acre there, and on a 30-ton crop, the difference between 1.5 and 1.0 can be $200 an acre.
So $300, $400, $500 an acre.
Right off the top, right there. It's incredible. That's why I say on the payback, it really depends on the crop, on the surge system, what you're doing. And then in nitrogen, on corn, the other big thing is we run a feedlot, we fatten, we buy calves, we back around, we fatten. The feed conversion is better when the nitrogen isn't too high in the cow feed, in the silage. If you have silage that's green all the way to the end, and how many people went by a cornfield and the bottom 3 feet of it's fired up, you know, it's brown and the top's green, it didn't have enough nitrogen, or you've seen it where they're green all the way to the end and they chopped it down there and the stalks are green. Everything's just green as a gourd. Well, odds are it's got too much in it. And you can actually end up having to go buy other products or feed less of it because you have too many parts per million of it. Like across the Midwest because of the drought this year. There's a lot of dairies that bought, and feedlots that bought corn that only got like this tall, but it was fertilized so heavy, they can't use a lot of it. So they gotta go buy other products like distillers grains to add to it, because it literally can kill the cow with too much nitrogen. And let's say if you have like an 8 parts per million on the feed, if you can drop that to like 6, you can gain 1/10 or 2 per pound per day in the gain. Everything comes back. It's sometimes you don't know. Without the program, like the CSP program, you don't think you have the time to, look at all these things. And because of a program like this, you learn what you're losing on the backside.
So tying it back to that program, I guess, the idea behind CSP was, it's an incentive to get some producers to do this, get the word out, and so the people will do it on their own. I mean, good conservation, like they always say, is supposed to pay for itself, you know, and that's the idea. And it doesn't always work that way. It seems to work on some of these, and that's why we wanted Richard to talk about some successes that we've seen using these programs.
So I had my tonsils out about 12 days ago, and my voice was a little lost, and I sound a little funny, but.
Hey, Rory, have you guys had a comparison under center pivots versus this with, I mean, obviously not the surge valve, but the same scenario he's saying of the testing and whatnot?
Not of the plant tissue testing that I've got back yet. They're a couple years into the CSP where I've got one that's new that will get some results under a pivot, but I don't have them yet. Be at the end of be October.
That'll be an interesting comparison.
It will be.
It will be very interesting, because like pivot.
So you did, I know you did it on beets. Did you do any plant tissue testing on?
We do it on wheat, we do it on, you know, what do we sign up for, 300 acres? It happens on like 2,000 acres now. It happens everywhere now.
But did the CSP, I mean, I know you guys are thinking about it, did it get you over the hump?
It did, because we wouldn't have done it without it. I mean, we might have eventually got there because of these numbers right here. Because it's bad, you don't want to be 1.5 with a 16 or 17 or 18. Because this really hurts you, this number here. So we'd have eventually figured it out, possibly, but we wouldn't have known the extent. And the other thing, the reason I think CSP is another good program, because when people apply too much nitrogen, it ends up in the waterways. It ends up in your wells. It ends up everywhere it should. Especially in maybe farming communities where maybe even irrigated communities. You take somewhere like Burlington or Emblem, their water tables they can get a well, they go down 10 feet, water's everywhere. Well, anything that goes with that water off the field goes into that well, goes into the house. It's there. Anything you can do to reduce that helps everyone, everywhere.
So are those surge valves, where are they getting their power from?
They are, that's another great thing. They're batteries and they're solar powered. They don't need electricity. Now, it gets off the subject a little bit, but the next step that happens here that we're going to do, I think Rory's worked with some people in the past. They have, we have a subsurface drip as well. Well, in that, and you fill it with water, and it comes over here to a hut. It's on an antenna. And what it does, and there's these sensors across it, go across it, and they're down inside the tank. They go down from top to bottom. They're arranged all over in there. And it measures this measures everything, temperature, wind, everything to do with weather. This measures the amount of evaporation in it. Well, we know how much corn takes past tasseling, or before tasseling, right when it's in the milk stage, it takes a 1/4 inch of water a day to survive. Well, what happens is this comes in here. You know you've lost 3/10 today because of the outside moisture. And on our subsurface, it's a lot easier to control. But this then goes into a computer, and it tells these, it automates. Basically, you automate on this underground line here, where all these surge valves are. These butterfly valves, you take off this manual controller, and you put an electronic controller. And they talk wirelessly. We should have ran, this is hindsight, it's 2020. We should have ran conduit, every one of these. They don't have a strong enough valve, electric valve and motor, to turn these things with solar right now that works. So it would take real electricity. And then, so you have your main control box right in here that knows what it's losing a day. You put on an electric valve, and it automatically, according to conditions, turns these on. It knows whether the vents, whether it needs to run for 4 hours, 6 hours, 8 hours, and it does it every day. That's the next step in this process. It becomes completely automated. And the other nice thing about this is we have a field. This is part of the reasons why pivots don't work over where we are, because we're in a small valley. It's not laid out. The river doesn't run east and west. It's real short. So we'll have like a 40 here, and then the neighbor will come right up into here, because it's like a sawtooth, all the property lines. And the fields aren't laid out with north and south direction. This will be 40 acres. This will be 70. So we'll have a 110 acre field. Now with the surge valves, we can set this field half the acres at one time. If this was a longer field, it'd be bigger. So in a 12 to 24 hour period, this whole thing can be wet once. That's absolutely incredible. If anybody's ever tried to irrigate in corn or beans, a field like this, we have it stretched across. Now this field, literally on these, we literally get this acres wet in 24 hours. Really wet, they'll be set for weeks. I don't know how to explain how nice that is. I really can't explain how nice that is.
So in doing that, you're putting on a higher volume compared to what you used to do in a 12-hour set?
Well, less. We're putting out, you kind of missed some of the beginning, didn't you? You missed a lot of the beginning. I wish you would have.
Well, I know you say your water use was roughly half of what it used to be. My question is, to get across that field faster, do you try to shoot a higher volume for a less
No,
time?
less.
Okay.
Less.
Huh.
Because it takes, if you put water down a road, you got a road. If you, I should almost go back.
It has to do with that soil tightening up.
Yeah, tighten up.
So
You missed
this
all
surge
the-
is, and
It's
they stop
recorded,
it
no
tight, so
worries.
the next time it comes across, it just goes across it, real quick.
If you ever irrigated and you couldn't get that water road to the bottom, you've left it on for like a day or 2 days or something, but then you shut it off, you come back after 24 hours after it's soaked up, you put it on there and it just goes, like, why the heck didn't it do that the other day? It's the same effect, but it happens quick.
Okay.
Oh, thank you.
Big Dixie.
Thank you, Dave. We've stretched, in row crop now, we have fields that we, like this field here, it's half mile length. We would used to have to come down here and run a line and turn it into 2 quarter-mile fields. In row crop now, it'll stretch all the way across, and the top's as wet as the bottom. I can't say enough good things about it for our situation, I guess.
One thing that I hadn't talked about, our state office, the engineers really fought with us on this system, because this has been tried around here. And I know the experiment station had tried this, but what they did is they did a surge valve, and then they still ran 30 joints of pipe this way, 30 joints of pipe that way, so you still had all the human error in, and somebody go out there and move the gates, and that human error was a big issue. Well, we planned some of these first ones based off what Schlenker found on other properties. We got one good one going in here that's on the real flat ground, so we'll see how it works in the Powell area. But they said you can't do that because it's basically just making it easy for the producer, and all we need to do is improve it so that the resources are there. And I said, okay, then how can we do that for pivots? I mean, we've got pivot controllers and computers on pivots now. Well, we shouldn't be cost sharing on that. Well, once they realize if you take the human error out, we don't have to worry about somebody forgetting, and this even would do it more.
Yep.
So I could see a cost share retrofit in the future where you would trench in electricity.
Oh, yeah,
For
see,
the
because-
purpose of being able to have more of an automated system and taking more error.
Automation is, and I kind of skipped over a part on the automation here, it'll make a little more sense, because you don't just use this used in conjunction with the water, you go out in the field like this, and you place water probes, water sensors out in the field across there in a grid, and they go at the levels. You can do 3 levels, 5 levels, 4 levels. Like your first one, the probe comes up and they talk wirelessly to this station here, as well as with this evaporative pan. And they'll go in, the first one might be, if this is your soil, the first one might be at 6 inches. And then your next one will be at a foot, and so on, to 18 inches to 24 inches, to 30 inches, depending on the crop, like if you have shallow root crop like barley, where you would need it. And you would program in there that it doesn't need to, we don't need to kick this system on, no matter what this is saying, until we have reached level 18 on the cornfield or sugar beet field. So these two go hand in hand. So if you've got your probes out in this field and it's really hot and it's wilting down, but if you still have adequate moisture at the 1 foot mark and you can draw down to the 24-inch mark, you don't go, it changes the way we irrigate. You don't just irrigate because it's Monday. Every Monday we irrigate this field. You use this is really the next step, because then this tells this, even though it's hot, and then once you have that, the data tracks and you can follow it, and you can I'm not using that words here, you can build over time your stats, and you know what to do, and you know whether you should have been doing it to 12, because you can take your yield into that, and what works better. It's really amazing what's come on in the last 5 to 10 years. Vegetable farmers have really brought a lot of this on, like lettuce. They come up on beds. They don't do it under pivots. They do it under. That's what makes these still common. The surge valves in California and high dollar vegetable farms and fruit farms. And the things the way they've got automation set up on those now is really incredible. And that's the basic principles of it. And then you're not going out. I don't know how much you can improve it, because we don't know yet, because we go down there, we look at the field, and it's wilting, and you can dig it up, and then you know when to go back and when not to go back. But if these are already out there, and they're telling you, you just click up your computer from your house, and you go, well, it's time to do, like the pivot people can. And you just click on it, hey, it's down to 12 or 18, we just need to kick it on. And then you might be able to go 10 days, 14 days, or 2 days, or 6 days, or maybe you figure out you should have been running back quicker. All part of that equine program and the surge valves.
Have you had long enough watching this deal to compare it before and after on the 1 CFS per 70 that the allocated water rights are? Or are you seeing that it's...
Yeah, it helps there immensely. We can do, I don't know if you could get away with actually just 1 CF. It goes back to the crop there again. I don't think, because each crop uses more or less. I think on dry beans we can get away with 1 CFS, but I don't think we necessarily could with alfalfa. I think alfalfa is one of our highest water users to do it like you should. And sugar beets are pretty high, and corn is pretty high actually. But the trick on corn is, if you can get your profile full like the 12-inch or 6-inch mark, you can cut it off way quicker than people normally do. So
Do you guys have an impeller that's tied to this, so you're knowing exactly what you're?
We know exactly, on our pump systems, we know, yeah, on the Grable River, water
There's
is
no pump actually, not gravity.
on a lot of these, and we have a lot of gravity systems now too, but yeah, on the pump stuff, we know exactly what goes in. Water on the Grable River is, you know, every, down to like the 100th of a foot where that stuff's going, so we know exactly everywhere everything's going.
This gravity system we got here in Cal, it's coming out of the canal and we just put in a brand new calandra screen, and a staff gauge. So we are breaking it over a weir and then, so we're measuring it right there. And it's only feeding this complete surge valve system on that field. So it's not, you know, continuing on to somebody else's place, so we'll know that real accurate as well.
Yeah, that'll be interesting to see how the numbers come out.
Right, because before this system, it was in a buried line to a bubbler, and then it ran a gated pipe across the whole deal. So it'd be a real good comparison, and it had a staff gauge then too. So we'll be able to compare what it took to irrigate that field last year versus this coming year.
I think it'd be really interesting to see on flat. We just don't have flat. In general terms where we want.
Where are you guys at?
We're on the Grable River between Matisse and Burlington.
Okay.
You know where Roach Gulch Dam is? We're on all around that.
Okay.
We have a feedlot on the north side of the road there. You know where Kyle Canyon is? You go up
Mm.
right there. The
Any other questions? Richard?
So cost per acre with everything put in, is it comparable to a pivot or what is it?
yeah, it's just every bit as much.
It's about as much as a pivot, yep.
But it helps us because we have, well, we got that. There's just no where to put it. It's just
Right.
odd.
Because they're, you know, it's not an electricity savings thing because they're pumping already, but that was just how it is. It'll be interesting on this, you know, I know a lot of guys around here and I agree with them, is there is certainly the concern about the electric costs in the future. You just don't know where those are gonna go, and if you're tied to it with a pivot, that's something that's hard to plan for. So if you can do it in a gravity situation and get similar efficiencies out of this, then, you know, we're trying to put a few of those in.
Yeah.
They're not perfect. I mean, it's not perfect. I mean, water's got to be really clean for this work. And if you have any kind of head pressure, I really wish somebody would come up with a better way, because these things, when they switch, and that valve in there switches in that circle, it's going this way. And you got the butterfly valve right here, it's diverting it that way. Well, when it starts to turn, you can change it to open, you can change it to be 30% for 2 minutes or 1 minute to kind of equalize it. But whenever it goes shut, that thing wants to go that way. And there's no good clamp hold on. So what you end up with, you can go anywhere and see the university. We end up basically just putting two clips. And that's not good. I mean, and nothing, it's not perfect. And it's a lot of, you know, a lot of work to stretch your pipe out 5 this way, 5 that way, 5 this way, 5 that way, compared to just laying it out. But you don't have all that leaks. Leaky pipe ruins so much crops, because then you get that circle up there where it leaks out, and it's always a wet spot. So if you're trying to get back in there, if you're carrying, you can't carry water in gated pipe. It wasn't meant to be carried. You lose it. It really makes a mess. And then this is just on for that 6-hour period or 12-hour period, you're done. And the water you apply to that field stays in. I don't know how to stress that.
So in your ranking versus a pivot, you're seeing efficiency similar, so you're ranking?
We don't rank pipe systems with pivots, so we have separate accounts for those anyway. But when we rank a complete gated pipe with surge valve, it's at the top of the line. So if you go from dirt ditch to concrete, dirt ditch to, you know, gated pipe to complete, you know, it gets the most preference.
I think they probably, even in their book, they run about 85% efficiency. I think so.
Yeah.
I really believe that. The pivot must be 80 to 90%.
Right. They're about the same. About the same cost, about the same.
They are really close to the same. It gives people an option who can't use pivots. Or if you were a vegetable farmer, you couldn't probably use a pivot anyway. And there's certain things, we do a lot of dry beans. Pivots cause dry beans to, it's quality. Like you're raising seed, it's not so much of a matter, but we do a lot of commercials. That white, that brown and bright white, a pivot, that constant rain, they don't hold their color. They start losing. So there's other reasons people don't necessarily want to go to a pivot depending on the crops raised. And it's a nice option besides, and the other, our neighbors that have a pivot, let's say you had a perfect 160. Well, you put the pivot on. I can't draw very good circles or very good squares, I guess. You still got, if this is a 160, you might get 140. You still got these corners that you were farming before. And the neighbors I've seen, and it's not everybody, they either give up on their corners or they spend as much time going to these corners and irrigating as they did setting the whole field to begin with.
Sometimes they'll end up, if they were in gated pipe, they'll end up with about 80%, they'll use 80% of their gated pipe to irrigate, or 80 to 100% of what they had to get the corners.
What I've seen a lot is, then that's where their hay stacked, or they put their grain bins, or they start parking equipment. But you start,
Or they subdivide that.
yeah, they subdivide and put a house on it. But you start losing something that you had before. That's what I've seen, and and there's so many good things about things. I'm not trying to say they're bad at all. There's a lot of good things about it. Just like there's a lot of good things, there's bad things about that. It's just one of the things I've noticed as far as time savings. They've got a set roughly. They go to almost as much work to set this. They just use a little less water than wasn't coming all the way through.
Yeah, I think the intent on the pivots was,
Where you have more land than
here, the value of an irrigated acre is so high that guys will run their own pipelines to set
Yeah,
up
from here.
risers and, alfalfa valves, and they'll go ahead and do those corners. But the idea, I think, is to just plant those, get them in established cover and not worry about them, but that almost
They
never
came
happens
into
here.
play in places where they were supplemental irrigation. So you knew if you were in Nebraska or Iowa and you had a 160, 140 of it was going to be really good. And this, you'd still have an excellent crop. It wouldn't be as good as this, but you would still have a way to get your water. That's where they came about when we started moving them to all irrigation crops, what I'm trying to say. So a lot of places, these corners aren't lost. Like if you're in the middle of Iowa or Nebraska, a lot of them in Nebraska, these corners aren't lost. Instead of 200 bushel corn, you got 100 bushel corn. You only got 13 inches of rain instead of 26. You have a way to still irrigate. And out here, and the other thing about this system versus one of these, you can catch up. Like if you get behind, something happens, you can fill your water profile back up. Where a pivot, if it gets real hot, and you get behind, like if it's broke down for a week, it's hard to catch back up. Really hard to catch back up on a row crop. Or if you want to shut it down for 3 days, dry it out enough to go spray this field, and then turn the water back on. If you do it at the wrong time, you'll be playing catch up the rest of the year. Where there you can get your profile full so fast. Okay, because you can just apply more water to the field in time and fashion. It's still flood irrigation, still furrow irrigation.
All right, well, thank you very
No
much,
problem.
Richard and Lori. Thanks.
Thank you, I'm sorry. If you have any questions, you can call me.
You can leave your